So as I was going to show, this is the repo as it's cloned down from Lambda. There haven't been any changes made to it. And I was just showing that here in the source file, your README that you get covers a lot of the moving parts that are going on. So I was saying you need to look over that in terms of, this describes a lot real briefly of a lot of what these files are. What my point was right now is you'll notice there's a make file. So if we call make from here, it doesn't find it. But if we just cd into the source, of course, then we can call make and we get a whole lot of problems. So that's the first thing we're going to talk about. Get error, use of undeclared identifier, response length, and we're actually going to work on that right now. And then we have a lot of unused parameters that are coming from a couple different functions. So the first thing, if we wanted to go in just to get rid of this undeclared identifier response link, I'm just going to go into server.c. And right here, we have an undeclared response length. So I'm just going to temporarily declare int response length equals 10, just something there. So we go down here and make this file again. After we save it, we get 11 warnings generated. Bede showed a trick in, I think it was last week when he was doing the LR8 of voiding out these. I know Frolwin and Nate were in there when he was doing some extensive debugging. I think Jarek, you might have been, I don't recall. But there was a way of voiding out. I do it a little bit different because I've had trouble getting the way. Remember when he just called like in parens void and then put the variable? I've always had trouble getting that to work. And so what I've always done in these defines, and this is just another way to do it, you can say define, and I'll just call it unused, and then P for parameters, since these are parameters that we're having trouble with, then say void P. Let's see, define unused P, void P. If we save that, and then if we just start from the top here, we see on 5151, we have 4 content length, body, content type, and header. So that's all going to be in our send that we're messing with right now. So if we just go in here, and you can actually just say unused header. You'll notice we had 11 error warnings, saved it, make again. Now we only have 10 error warnings. Okay. Am I transmitting okay? Somebody speak because I can't see the video.
Yep, I can hear you.
Cool. I just heard a weird noise in my headphones. So that's how I'm getting rid of all these. So if you go back and ran the make again, so we also have the content type, body, and content length. So I can just do the same. And then once again, if we run this, we only had we only had 7 warnings generated. And these, I could go through and get rid of all these, but you see what we have. We know these are going to be there. These are appearing in code that we're not messing with right now. And ideally we could go through there, but since we're a little bit shorter on time, I'm not going to go through all those right now. And we just know that we don't have any errors that are actually occurring. There's one right here, 147, warning control reaches end of non-void function. Get rid of that easy just by saying return null right here. That should actually get rid of that problem and bring this down to 6. Yeah. Okay. So we have talked about how to get rid of all these error warnings, and I have implemented that in, and this is just a useful thing like Beej was talking about, not only when you're tackling errors, tackling them one at a time, but when you have these errors that when you want to generate everything, so you compile it that way, but then you get a lot of errors because you have unused parameters and such, things that are not actual problems with the code. You just haven't got to coding out that part of the code yet. You can go back through and fix them like that. The other way Beej did it, he was just going in and doing something, if I'm not mistaken, like a void body.
It's actually the opposite. The void is in parentheses, and then body is just afterwards.
That's what he was doing?
Yeah.
And that does the same thing. Maybe I always had them reversed. Well, yeah, it still got rid of the body. Well, cool. Well, now we've got both examples of it. Yeah, I just had the parens reversed on it.
It's a little counterintuitive to do it this way, but
yeah, and I, the thing is that in the past he demonstrated it. I had problems with it, and it probably in my head stuck as the flip-flopped way. And I found this way and an explanation of why they use this way long ago. So I just always use this, then you just use the unused. Obviously, this is a little simpler and saves you some time. So that said, I saw him do it again, and I was like, oh, that's cool. I forgot all about that from back in the day. I'll try that out. And then when I tried it once again, I got the same thing. And it's like you're saying, it was just a little counterintuitive. So thank you for catching that. And yeah, now you've got both ways that we can do that. So we've got our warnings cleaned up to the point that we want to get them cleaned up. So we're going to go ahead and code up the send response to write both the header and the body to the response buffer. We talked about the sprintf yesterday that we were using, the sprintf, so we're going to utilize that. One thing I will show right now, if you actually do, now that we have to run the make file, if you run the server, do you want it to accept incoming connections, allow, and the server actually is connecting with everything that's going on under the hood that's been supplied to us. But if we go and do a second thing, and let's see, the command would be curl dash d dash http no s / localhost. What was it? 3490. And it was curl dash -. I think that's right. And if you go back over, you can see it got a connection, but it didn't get anything back from that connection. And that's because we don't have any way of sending a response or dealing with our responses right now. But we see the server's up and running. Actually going to go over and kill that right now. So basically, we've got to work on building an HTTP response and to store it in response that we have defined for us right here with the maximum response size that is declared as an integer constant above. So the first thing we need is the time, because we need a timestamp for any response. So we can say time. This is actually a data type. It's a weird data type. We'll just call it T. You can look it up if you're interested in more of it. But the basic of it is that it's of a type arithmetic, but it's not specifically an integer, a float. There are some problems that come about from it. But for RK, like I said, if you want to read more about it, you know, I've always talked. Does everybody here know how to use the man page that I was talking about the other day?
For C specifically?
Mm-hmm.
I don't know what the code is for that now.
Okay, so when you're in your terminal, anywhere in your terminal, you can just go in and you can say man. If you wanted to know, let's say, we're going to say time t equals time null. And we wanted to know more about this built-in function time. Section 2 of the manual is system calls, so let's man 3 time. And there you've got the library that it's included in, what you need to have in your header, and you've got a description of it, errors and whatnot. So anytime you run across something in C, if you don't feel like Googling, or you don't have the time to Google or to go search through a bunch of results, and you need the real, I guess you could say, the real nuts and bolts of what's going on, you can always go to the man page. Keep in mind when you do it, like I said, 3 is for library. If you do 2, that is for system calls. So you have to differentiate, because some of them have redundancy, and if you look up the wrong one, it'll populate, but it's not going to be what you're looking for. So like I was showing for this, if we say man 3 time, it tells us for time function returns the value of time in seconds and 0 hours, 0 minutes, such and such, January 1st, 1970, the same as we dealt with in JavaScript. I don't know if that's how Swift works. I know that's how JavaScript works. It's based off this time, and I think that's how all computing time that I've come across works. It does not include leap seconds. If an error occurs, time returns the value. The return value is also stored in a pointer tlock, provided that tlock is non-null. So we are going to get a time, and we're going to create a struct that holds all the different parts of the timestamp. And we're going to get the local time. And the local time expects a pointer to a time t argument, so we'll pass it the address of our time t value that we have using the and. So we'll make a struct tm pointer. We'll call this, we put an underscore local time, and then we will invoke local time. Remember, it expects a pointer, so we need the address of t that we defined above right here. To get out of this man page, you just hit Q as usual. So if you wanted to see man 3 local time, same thing. So that's always a neat way. Beej showed us that a long time ago, and Beej has pointed that out at least once. I think, I don't remember if it was in one of the QAs or if it was a meeting that we had, but that man page is always useful to go to. So just another little thing that doesn't directly relate to this project, nor did the voids, but just good points to bring up. And then we will make a timestamp here, and we'll just call it char. And of course, we are creating a string, past time, and we'll feed that local time. So basically, we're just using this function, the ask time, to convert the TM struct to a timestamp. There's one thing when we create our sprintf that we need to remember when we were working on the sprintfs, we had to put in a bunch of new lines. This actually, this uniquely returns a new line along with this timestamp that it creates. So we don't have to have a new line after the field that we will make, that we invoke, or that we create later on for this. Just something to point out in case that question comes up, and I'll mention it again when we're down in there. So I want to unhard code this out because now we're going to have a response length. So we will say int response length equals, and we'll format this the same way we did the other day for readability, takes in response. Now do remember in C that white space does not matter, but it's nice to keep this as clean looking as we can. So we will take in our first parameter and an n, and that is going to be the header. And then we will say the date. We will also take in a string for the format specifier. And remember, there's no new line here. So we'll be adding all these, but we're going to add the timestamp for this, but there's no new line because the new line has already been created here with this method. And we'll just hard code connection, close, new line, and then we will say content type. Give that a new line. And that will be the content type and the content length that we're taking in that we voided out earlier, but we'll deal with that right now. Then we'll have content length. Will actually be a number, so we'll just format specify the D there. And then we will just skip a space with a new line. And then we will have our body. Mind you, all these are being supplied by code that you've already been given, and we'll see that here in just a second. And a new line, comma here. So we didn't have a new line there. We've got new lines where we need S for date, S for content type, length is D, and go there. And then we will say header and timestamp and content type. If you've already looked at this, you know that you've got a helper function. I believe it's in here that actually gets the content type. This is all included in your README, but just pointing out one of those details at least. And then content length and the body, which is hard coded in. And if we want, let's put a print statement in here so we can make sure, put a print F, say built response. This is going to be a string with a new line, and we will give it the response that we just built. And then down here, we've already been given this code to actually send it back with the send function and our error handling and our return. So now let's see what we have. If one thing we've taken care of now is that we have dealt with header, content type, content length, and body because we've all got it included here, so we can get rid of all this. And we'll save everything. Make, still have our 6 warnings. We'll run our server. The server's still running. We jump back over to here. If we just run that same command, still getting an empty reply. And you still see that we got a connection. So we've got more work to do. Does anybody have any questions on anything that I've done right here with the sprintf that we already covered yesterday, with how I got rid of these warnings initially, with the timestamp that we're creating? Any questions to this point? Hopefully.
I'm just curious about the pointer stuff on line 62. Like, from what I understood about pointers, like when you want to set the address of something, it shouldn't have the asterisk. So I'm trying to understand like line 62 there, because you're getting the address from T, and then so I don't know.
Okay. Our variable local time is going to be a pointer.
Yeah.
You agree with that? That we want a pointer for local time. So we're going to call this built-in function local time on T. But local time expects, you can't put T here. We only got, we see this time T, this just returns a value. This doesn't return a pointer. This returns, when you invoke time, it gives you the value in seconds, an integer.
So you're saying that the local time function just like stores whatever time it is at the address
the local time function accepts an argument of an address to the time. It doesn't accept the value. It accepts it wants a pointer. So we're just simply dereferencing it.
Mm-hmm. Okay.
Does that make sense?
Yeah, makes sense.
This gives us an integer. We need this value for this, the local time, but because this expects a pointer, we just get the address to T here. That's all we're doing.
Cool. At line 76, I think you're missing a colon as well after content length. But that answers my question. Thanks.
Yeah, and I said dereference, and I actually didn't mean dereference, because dereferencing is taking the address back to the value. But what I was speaking of here is we just have a value, an integer that we get in time, all those seconds. But local time needs to accept a pointer, so we're just saying and T there to give local time what it needs. That's all that is. It's just what this is. I think that's the best I can explain it. Did you have any extension to the question, or is that good?
No, just because it makes sense with the local time function. So I wasn't thinking about that, because I think when you first mentioned it, it was something like you were talking about how the pointer needs the address, but that's not what I understand. Is that like you can initialize the pointer, and then, like, for example, if I was just associating the local time variable with like let's say it was an int or something. So then, and I wanted to give it the same address as another int, then I would just initialize it as a pointer and then set it without the asterisk and the
So you're
ampersand on the
saying
next line.
you would have just started this. It made this a pointer right here, and then just done that.
No, but it's not really related to what's going on here. I'm not explaining it well, so it's all good.
Okay. Okay, so then we made our print statement and we saved here, and we just showed that we were still getting an empty response here. So if you go down, something that you can do to kind of see, there's this 404 response, and it has already been built in right here. There's nothing you need to do to the 404. It's provided. And if you look at it, basically it is serving up. If you'll, of course, use this as someone puts an invalid route, and it's just going to serve up a 404 to them. And that's the point of this function. What we can do with this function, though, is that we can go to the handle HTTP request and actually invoke it. And that way we know, without having to build out the handle HTTP request first, we can go and just invoke the 404 response in here. Need to do it after. So we should be able to say and give it new FD so it works on the socket. And try to run it again. And if we run that same curl, now we get that 404 response and the actual body. So we can see that we're getting a response, and we can see that we're building out our response with this sprintf that we've asked for. And it's giving the content type, the content length, the connections closed, that was hard coded in. Here we've got this that was hard, that's into the function itself, the 404 right here. And we got our timestamp that we were working on earlier. And then we've got this raw HTML right here. So actually, am I unfrozen now?
You're back.
Yeah, where did I freeze off at?
You were just going through the response that you got from.
Yeah, so we got the response. This is hard coded into the 404, and then this is just everything we worked on in the sprintf. The content length, the content type, the connection, and the raw HTML. And what I was going to go show was that if we went to local, there it is already.
Can you share your screen again?
We go here to local host 3490, we get a 404. But if we went back in there and actually took out that 404. Ran the make and run the server. Get the bash. And now we just get that the page isn't working. So kind of just a quick little way that you can use and apply that to a lot of different things, but there's not really too much to all of that. Anybody have any questions to this point? All right, let me go back and undo this, and then we can work on run the curl again, and we get the 404. And another example, can anyone think of a problem, or have they already run across the problem when you use sprintf that works well when we're sending data in the form of a string, but can you think of a problem that could occur with that sprintf? Say something that may come up with it while we're sending things from our server. Remember, sprintf deals with a string. But what if you needed to do something like send an image that's just in binary data? It wouldn't work. So I can demonstrate that over here. Where is it? Right here in server root, there's this cat.jpg, horrible picture of a cat. So we want to send this cat. So if we try to send this cat using this sprintf function that we're currently using in the way that the server is set up, I'm going to show you what happens, and you can guess it's not going to function. So back to the server. And so what we can try to do, instead of sending this 404 response to everything, we can try to send the client the picture of the cat. Y'all will be working on the get file, but I'm just going to modify the 404 function in itself to show you how you can do it in case you haven't gotten to that point. So we're still going to invoke the 404 here in the while loop while the server's listening. We'll leave that the same, and we'll just go and change the 404 right here. It's going to be this line. We can change it to SN print, file path, size of file path, string cat JPEG. we'll have server root here, file path, size of file path, this cat.jpg, server root. We save this, make this. That's supposed to be a print F. Maybe that will work. All right, so now we got it running. And if we run the server, get that, go back to here, and we just get a blank page. If you come over here into the console, you get this message, error to load resource, error content length mismatch. So if you look in the browser console, we see that. And the reason why that's happening is that we're, like I was saying, we're using the sprintf to write the image data to the response buffer. And the printf and any print function variant is only able to deal with text data. So we're trying to handle image data at this point, and the printf is not handling that image data correctly. There's something in, I believe, in your facts that covers this. Right here, when I request the cat image, I just get a black screen reader in my browser. What's the problem? And you can go through and read more of this if you're interested. But basically, it's trying to treat the image like it is a string that's UTF-8 encoded, and that doesn't work. So it says right down here, the solution is that we need to write the image data to the response buffer in a way that is encoding agnostic. Something like memcopy would work very well for this, as memcopy doesn't assume anything about encoding of the data. So it's a minor detail, but it's a major problem in the sense that the sprintf just won't handle anything but the string. So what we can go and do is alter our code. Let me get back out of this, go back to here, just again. So this is correct what we need here. There was nothing wrong with this, but what we needed to do is alter our code here. What we're gonna do after, we'll keep the print function in for housekeeping, and we'll say memcopy response plus response length, the body, the content length. And this is just updating the response length with the new total length of our response after writing the body. So we can say response length plus equals content length. And we still have our same code here. So if we write the memory, excuse me, if we write our response in this agnostic way using the memcopy here, and we run a make again, same warnings, server, and now I should be able to go back and refresh this. What have I done?
It says in the FAQ here that to use Sprint F to make the header, but nothing else. So I'm not sure if that's something that is off or not.
Hold on 1 second. I mean, yeah, Nate, I think could you repeat what you said, Nate? Because I think you were, I just want to hear what you said again to make sure that I understood what you said, but I figured out what the problem was with it. I think it was exactly what you were saying, because you were talking about the body being here in the response length with the Sprint F.
Yeah, it says in the FAQ that it's only supposed to be the header in the Sprint F, and then you append the body afterwards using memcopy.
Yeah, I went through and I cleaned all this up, and when I was cleaning it up, we got the body out of there, and now we're just referencing the body here in the mem copy. If we go to, let's see. Make, run the server. localhost 3490. And there's our cat. Good call. Good call and a total mistake on my part. Like I told you on the beginning, sometimes I'll kind of stutter around on things or act like I don't know something to try to get some conversation going, but that was absolutely an error on my behalf, and I thank you for catching that. So yeah, what we ended up doing is that we continue to use the sprintf for the HTTP header because all we're dealing with, that's always text. No matter which way you do it or look at it, that is always text. So we're going to continue to use that, and the mem copy, of course, like I said, being able to handle the body. When it's just a 404 error, that worked fine because all we had was text in that HTML for the 404 error that we saw rendered both in the console and rendered out here as an actual 404 on the screen with the H1s and everything else. But when we tried to change that to the cat, we did not have the compatibility of being able to use that sprintf with the binary data that an image is. So we got around that with the mem copy and used the body inside of that mem copy, which is agnostic to how it reads memory. The only unfortunate part is that when I did it, I forgot to take it back out of the sprintf that we had originally had it in, and we got that result. So appreciate that. Any questions about that? Like I said, that was intended mostly as a run through on what ideally you should have already gotten done, or in the least, I mean, it straight up shows you how to deal with part of it. It shows you the general idea of how to deal with the rest of it if you already haven't implemented that. So are there any questions to this point? Anything?
No, that was helpful.
What's that?
I said it was helpful because I didn't know necessarily how to start, so it was good.
So got that, and then remember today, and that's why we went over this today, the arbitrary file serving. You will be implementing you'll be implementing it a little bit differently, but I wanted in here that you're implementing, but or excuse me, in your Git file, not the Git D20. You'll be implementing it here in your Git file, and that's how you have to deal with it. And when you're not able to use the sprintf. So if there's no questions from that, I'm going to talk a little bit about the LRU cache. That's actually part 2, but in case anyone gets to that today, we'll have a little bit of time to cover that. And we've pretty much covered the code that you need to do, or starter code that you need something similar to get you to the point that you should be at right now. So if you're not at that point, hopefully that helps a lot. If you were struggling a little bit yesterday, or you had some things going on, and if you're past it, sorry, but hopefully you maybe got something out of that review. So if you look at part 2 here, saying you're going to implement an LRU cache. Somebody tell me what an LRU cache is.
was hoping you could tell me.
Anybody?
Says what we've recently used.
What's that?
Least recently used cache.
Yes. Okay. You just broke up, or my computer broke up. Yeah, a least recently used cache. So this is going to the benefit of a cache itself, and we'll kind of be mocking it here, is it takes time to read the file off of a disk. You have to call the operating system to make it happen, which isn't the fastest thing in the world. Yes, we're only dealing with tiny amounts of time, but those little amounts of time do matter in the big picture of things. And if it has to go to disk for the file, it even takes longer. So when you save a copy in memory, then you don't have to hit the disk. And that's the idea of this cache that you'll be implementing starting tomorrow or today if you get through everything that you're supposed to be through today. So I just wanted to briefly cover that. If you give me 1 second, I'm going to open up cat. Anyone want a copy of this code that I did right here? So this is everything we've done up to this point. Like I said, you can't necessarily cut and paste all this into your own code, but this does give you an idea of that go through. Yep, so you have everything that we did in the send response, the little bit that we changed in the 404 to make the cat image. Obviously, that's not a permanent change. And then I just did a return null here that got rid of that warning. And then inside of the int main, I invoke that response once again with this socket information just as a test. So a lot of what I've done is a test, other than basically I've laid out how to get your response formatted and how to be able to handle files other than pure text in the string format, and how we use that mem copy to deal with the body when we were sending that cat image. So I'm gonna go ahead and shut this down. And the curl command that I was using before I was using the browser, if you want any of those curl commands, I believe in your README, oh, where is it?
It's at the top of server. What is it? It's server.c. There it says.
Oh, is it in the
test with curl? If you don't have it, install it. It's at the top of server.c.
Yeah, right here are your curl commands. I just cut those off on accident and when I posted that, but just know that in your actual code that you've got right here, you've got your curl commands that I was running, and this is your D20. That's another thing you've got to implement that I was showing. And then you've got your date as well. So the D20 is this piece that you've got to implement that I mistakenly identified as the get file. So any other questions about yesterday or today's MVP, anything that I demonstrated in the code before we talk a little bit more about part two for it. I'm not going to spend a whole lot of time on it because I know most of y'all are catching up, but any questions whatsoever about what we've done, any of the C itself? Give everybody a 3-minute break. So, well, make it 5. Come back at 40 after the hour and we'll run it up to lunch and we'll call it quits. But take a 5-minute break since we've been going for over an hour right now. And we will talk a little bit more about the LRU cache when you come back, and then you'll be out of here for lunch. Be 41 after the hour on whatever time All right, is everybody back? So up to this point, like I said, if you hadn't gotten started, you've got pretty good code to get going with as far as dealing with the header. And we've seen also how to deal with files that are not of string format. So today, if you're coding out part 4 or part 4 of part 1, the MVP for today, you've got that memcopy function as an example and kind of steered in the right direction. So the other thing I want to talk about in case people are moving forward, as 401 identified, the LRU cache is a least recently used cache. So as we're calling things, as we were talking about, and having to get things off the disk, that takes time. So if we've got a cache and we can just access that cache, just like your internet browser does, we're going to be able to load quicker. So just to kind of demonstrate something out, say you had right here, server requests. And then let's say you have a cache. And then we had a cache, get that so it's not picking up in the C anymore. And then on the disk, we had, let's say, index.html. We had foo.gif. We had bar.jpg, style.css, and bar.html, and foo.js. I don't know. So every time the server, let's say the server makes it says get index in the proper format, it said get an index HTML. Well, then index HTML would go into the cache. This cache we're going to say is a maximum of 3 length, just for demonstration purposes. Then our server says get bar.jpg. So now bar.jpg going here, and then say it asks for foo.gif, and we foo gif goes here. What happens when we ask for foo.javascript though? What happens to the cache when we ask for foo.js?
It needs to remove the index in order to make room.
We're just going to do that. Think in terms of efficiency and whatnot. What would be a data structure? You know, if we kind of have something at the beginning or the end of a list, what would be a data structure you might think of that would work well to implement this cache?
A linked list would be good to remove from both the front and the end.
A linked list. So you've got O to the
doubly linked list, right?
Okay, yeah.
Okay.
So yeah. Good call there. So a linked list we can add to the head easily. That's O to the 1 time, but adding to the tail is O to the n time, if you remember. But we take away that problem with a doubly linked list, and that we can, because we need to always be able to add. Think of this as the head. The least recently used, of course, is the name of it, because that's the piece that's falling off. But when we're adding here, we're simply adding to the head. When we add to the head, once this cache is full, and remember we're just using 3 here for demonstrative purposes, we also need to be able to remove from the tail, because that doesn't magically happen. So now we've got those both in O to the 1 time. What though, the whole purpose of the cache is if we're doing something, we need to be able to see real quick, is this in the cache or do we need to go grab it off the disk? So
you need a dictionary as well. Or a hash table, sorry. Hash table.
Yeah, because with a doubly linked list, you've still got O to the n time for a search because you've got to iterate over that list. So like Nate's saying, with the doubly linked list, to get that to O to the 1 time or near O to the 1 time, remember the hash table in itself often has a linked list implemented into it. When you have the collisions to handle collisions. But the hash table you'll be dealing with today, you can actually, or when you get to it, you have your helper functions here. That's something I wanted to point out. I'm sure everyone knows this. I didn't hear it from any of y'all, but someone asked the other day, like, what the .h was. And if you didn't happen to know, those are just the header function, or those are headers. So it's the same as defining something in one file and then invoking it in another. So you see, you have meme.h here, you have in C here, and then actually in the server.c, you can see that we have those included, and you just include them with the quotations. These are all predefined. These are all user defined. We program those. So that's what the .h is just being able to reference these functions or whatever you've got in there in multiple files in C. I remember the same question came up in Python at some point. So in case that wasn't really clear, any of these .h files are just helper files. We can include them anywhere else in the program with the correct path if there's a path, but these are all sitting in the same dir. So another little side point to make there. Your hash table is here. You can take a look at it. It's a little bit more complicated than the hash table that you implemented in Python before, but you do have an underlying hash table here, so you do not have to worry about that. It does everything for you. So yeah, we're going to have a doubly linked list to be able to remove from the tail and add to the head in one time, and then we're going to put a hash table on top of that so that lookup is O to the 1 as well. So now all your operations in the LRU cache will be O to the 1. There's just another little piece of information to go with to kind of get you going in the right direction if you get to the LRU cache. So once again, wherever you're at, make sure that you've read over and you understand what you need to do. Make sure you're aware of the files that are involved that you are working with, that you understand what's going on with them, that you have a plan that you come up with beforehand before you go trying to tackle any of this. And if you haven't already done so, get the arbitrary file serving working today, the end of step 4 of part 1. If you're ready to move on to part 2, move into part 2 in the LRU cache. Beej should be having, like I said, the Q&A at 2 o'clock, give or take again. So I encourage everyone to be in there if you can. We will have one-on-ones today, like I said, between 3 and 4 p.m. So be by your Slack. I'll start calling people probably around 3 p.m. So just be watching. Those are quick, 5 to 10 minutes a piece, just to get an idea individually where you are. Remember to write down your questions, both for the Q&A, for the one-on-one, for stand-up, for any of that, but especially for the Q&A. Make sure and write down anything that you had to ask for Beej. All right. Anybody have anything else at this point? Cool. Let me know if you need anything. DM me. It's about time for lunch. When you get back from lunch, have about 2 hours to work on your code. Keep pushing up as you make changes. And let me know if you need anything, and we'll see everybody in Q&A at 2 o'clock with Beej. Be looking in the channel for that to post if you want to be in Q&A.
Cool. Thanks, John.
Hey, no problem.
Thank you.
Yeah, no problem.